Hi, I'm JD, and in this lecture, we're going to go over decimals. We'll also go over square roots and maybe Pythagorean theorem. So this is what we're going to go over. We're going to start with place value and rounding, addition and subtraction of decimals, multiplication of decimals, division of decimals, and conversion of fractions to decimals, and perhaps we'll do a little square roots and Pythagorean theorem, throw it in there for fun. All right, so here are the place values. So notice with decimals, well, with regular place values, whole numbers, you have ones, tens, and then hundreds. And that's split up by a decimal. And then notice when you get into smaller ones, it goes by tenths, hundredths, thousands, 10,000s, 100,000s. This is because we have a 10 base numbering system. All right, so how would you write this name, the word name for this number? 1,788 and 45 hundredths. 45 thousandths. So first, that decimal separates the whole number from the fraction amount or the decimal amount. You could say the whole thing's called the decimal. So you would separate by the word and then to do the decimal portion, you would say 45 thousandths. So you would say 45, whatever the number is, and then that last place there that appears here, wherever this number appears, you're going to say that place value. So the whole part would be 1,788 and decimal 45 thousandths. All right, so now let's look at a different type of an example. We're going to write this as a fraction. Now, to write a decimal as a fraction, you just have to pronounce it out loud. So this would be 876 thousandths. Again, look at that last place value. And then it's easy as that. You just pronounce it and it tells you how to set it up. So it'd be 876 over 1,000. Now, if it tells you to simplify it, you would. All right, so let's look at example number 3. Now, this is asking this, write it as decimal notation. So you're changing it from a fraction to a decimal. So you have 532 hundredths. So what you can do first is you can convert it to a mixed number. So that would be 5 and 32 hundredths. Why do that? Because if it's larger than the number on the bottom, it's going to be the whole number portion of the decimal. It's going to be in the ones place or whatever. So it'd be 5.32 or 5 and 32 hundredths. All right, so now let's do some rounding. Let's take 3,872 and 2,459 10,000ths, and let's do some rounding. So let's first round to the thousands place. The thousands place is there, so we look at the decimal place to the right or the digit to the right, and since it's larger, since it's 5 or up, you're going to round up. So it's going to change to a 6. So now it's 3,872 and 246 thousandths. All right, let's look at the next one. it's telling you to round that number to the hundreds place. There's the hundreds place. So that 5, which is to the right of the hundreds place, which is the thousands place. So that tells you to, since it's 5 or up, you're going to round up. So that'd be 3,872 and 25 hundredths. Letter C and letter D, now we're looking at the whole numbers. We're looking at the tens place and the hundreds place. And notice what's going to happen here and how it's different from rounding when it's one of those smaller place values. So we're going to round to the tens place. That 2 tells us to round down, which means that we're going to keep the 7 the same. So we have 3,870. Notice that here you have to put a 0 as a placeholder. And we'll do the hundreds place now. So it's we're going to round to 8. We need to look at the place value to the right, which is 7. And 7 would tell us to round it up. So we round it up to 3,900 or 3,900. It's fine if you say 3,872.2459. I'm just going to be, for the most part, I'm going to try to pronounce it correctly so that you can get used to it, because it's going to be helpful elsewhere. All right, so what do you do when you're adding decimals? Well, when you're adding decimals or when you're subtracting, it's better to write it vertically. Now, the other thing is you have to make sure that the decimal lines up. And on top of that, put zeros as placeholders. So you would add 7 plus 0 plus 7 plus 0 is 7. 2 plus 3 plus 0 is 5. 4 plus 2 plus 1 is 7. Just bring that down, that decimal. Decimal is lined up. 3 plus 4 plus 0 is 7. And then 1. So it's 17 and 757 thousandths. All right. Some of these are not as perfect as I want them to be when it comes to the subtraction. You're going to see later with the division how it's a little messed up. The reason for that is because a lot of steps are going on. All right, so with subtraction, what you want to do first is you want to line up the decimal, and on top of that, always put the larger number on top when writing it vertically. So we subtract, put the line in there, we subtract 8 minus 0, that gives us 8. 2 minus 9 gives us a negative, so that means we need to borrow. So we're going to borrow from the 5, we're going to cross that off. Cross that off. That makes it 4. We're going to then leave a 9 with that 0. And then we're going to put a 1 there. So now it's 12 minus 9. That's nice. That gives us a 3. 9 minus 0 is 9. Again, bring down the decimal. This is 14. We're going to need to borrow a 1 again. So that's 14 minus 7, which is 7. So the final answer is 7 and 938 thousandths. All right, now let's do some multiplication here. Again, I'm going to write it vertically. You can easily do this on a calculator. So now when you're doing this, it's different. They don't have to be lined up. You just have to line up the digits. Ignore the place values. So this would be 3 times 148, and that gives you 444. Then you do the 9, which is like 90, and do 9 times 148. So that put the 0 as a placeholder, and then 1,320. Now, with long multiplication, you would add these two numbers together. So 4 plus 0 is 4. 4 plus 2 is 6. 4 plus 3 is 7. 3, 1. Now do the decimal place. And if I count here, there's 1 and then 2. So I would do 2 decimal places, 1 and 2. And so my final answer is 137 and 64 hundredths. Now, what should happen as well, what you can do is estimate. So you started with something that's about 15. Let's make this, I guess we could, let's just make it 10 for simplicity. So 14, so 15 times 10 would give us about 150. 150 is 15 times 10. So that gives us about where we are in a ballpark. So you can always estimate to double check yourself. All right, so now let's convert dollars into cents. And cents is like a percent, so you would move it 2 decimal places. So that would be 4,503 cents. And that's how you would convert $45.03. Now, how would you convert cents to dollars? You just move the decimal place over twice. So 1, 2, you get $68.75. All right, so how do you divide a decimal? Well, you have to use long division, unless you're using a calculator. You have to do some long division. So first you would see, okay, how many times? Well, first what you would do is the decimal you just bring up. Wherever the decimal is, you just bring that up. So then you have, does 6 go into 5? No. Does it go into 51? Yes, it goes into 8 times. 8 times 6 is 48. Then you subtract, so that'd be 3. Bring down the 7. So how many times does 6 go into 37? 6 times. 6 times 6 is 36. Now you want to subtract these. 37 minus 36 gives you 1. Now we need to bring down the 2. So how many times does 6 go into 12? Twice. Subtract, 2 times 6 is 12. So then you subtract. That gives us 0. We are done. Now, sometimes what might happen, you might need to put extra zeros on the end, or you might have to put zeros as placeholders when you're doing this. All right, so let's look at another example. So we have 4 and 824 thousandths divided by 4 and 8/10. Well, you can't just divide. What you have to do first is you have to shift to decimal. Whatever you're dividing by, you want to make it into a whole number. So you want to take the 4.8 and you want to move decimal place over once. And whatever you do to one of them, you have to do to the other one. They're kind of like fractions. And in a sense, what you're doing with this one is you're multiplying both of those by 10, the top and the bottom, so it's similar to fractions. So those are the numbers you're going to be dividing by, you're going to be using. So 48 that's what you're dividing by. You're dividing by 48, and you're seeing about how many times does that go into 48.24. So does 40 go into 4? No. Does it go into 48? Yes, it goes into it once. Slightly out of order. That's okay. So 1 times 48 is 48. Now we subtract. So that's 0. Bring down the 2. All right. 48 does not go into 2. Bring down the 4. Does 48 go into 24? No. 0. Bring down the 0. Does 48 go into 240? The answer is yes. It goes into it 5 times. Now, if you're not sure, you can use estimation. So it's around, 48 is about 50. 240 is close to 250. So that means about 5 times. 5 times 48 actually gives us 240. So we would subtract, we get 0, so we're done. Now, here's another way to convert. So one is long division, converting a fraction, taking a fraction. We're going to see this in a moment. But what you can do as well is if you can easily multiply the denominator by a number to make it like 100 or 10 or 1,000, any of those base 10 numbers, or 10 raised to a certain power with exponents, then that's way easier than dividing. So with this one, 25 times 4 does give me 100, so I can multiply the top and the bottom by 4. I get 56 over 100. Therefore, my answer, converting this into decimal notation, would be 0 and 56 hundredths. The other way is long division. So 3 divided by 8, or 3 over 8, is the same as 3 divided by 8. So you're seeing how many times does 8 go into 3. Now, a way to check yourself with this, if it looks like an improper fraction, then it's going to be larger than 1. If it's a proper fraction, it's going to be less than 1. So that's a way that you can check to see if you're on the right track or not. So let's see how many times does 8 go into 3. Well, it doesn't. Does 8 go into 30? Yes. It goes into it 3 times. And notice that I just brought up the decimal. You just line it up. And then you pretty much ignore it. So 3 times 8 is 24. We're going to subtract that. 30 minus 24 is 6. Let's bring down a 0. Does 8 go into 60? Yes, it goes into it 7 times. 7 times 8 is 56. We're going to subtract that, so it gives 4. Bring down the 0. Does 8 go into 40? Yes, it goes into it 5 times evenly. Means no remainder. So 40 minus 40 is 0. So that means we're done. So the final answer is 0 and 375 thousandths. All right, so let's bring up different types of decimals, and different types of decimals that you might come across when you're doing long division or something else when you're converting it. You have terminating decimals and repeating decimals. So what's a terminating decimal? A terminating decimal terminates. It ends. And what are some examples? Any of your run-of-the-mill average Joe decimals. Anything that ends or doesn't repeat would be a terminating decimal. So what would be a repeating decimal? Well, what is it? It's a decimal that never ends and it repeats. What are some examples? So 0.333333. So you have 0.636363 and it repeats. And then 0.63 with the line over it means it repeats the whatever the line is over. So here it's repeating the 63. So I can easily have written this first one right here as 0.3 and put the line over 3 and didn't have to do all this. So all these are repeating decimals. So if you have decimals either like this or like this, you can always convert it to a fraction. All right, so here's an example of 7/11. And so I did, how many times does 11 go into 7? And you can kind of see my work there with the long division. And then notice that the 0.63, you can kind of see the pattern, like you have 66 and then 33, and it kind of repeats. When it starts repeating and you kind of get into a loop, you know that it's going to do the same thing over and over again. So you would stop and say, okay, this is a repeating decimal, and I can write it as 0.63 with a line over what repeats, which is 63. So it would be 0.63 repeating. All right, so what about rounding repeating decimals? And this can be kind of tricky, but what you're going to do is just extend it to what you need. So we're going to round each of these to the tenths, hundreds, and thousands. So 0.05, looking at the hundreds place, rounding the tenths, I'm going to round it up to 0.1. 0.0555, I can extend it further as needed. And so the hundreds place, I have, that's a hundreds place there. Look at the thousands place, I'm going to round up. So it's 0.06. Looking at the thousands place, round up. So I'm only going to round this 5. So that's why it's 56 thousandths. Now with 0.47 repeating, again, I can extend it as what I needed. So you'd round there to 0.5. For rounding it to the hundreds place, you look at the thousands place and you would round down there. So it's 47 hundredths. And then extending a little bit more. Again, you just want to extend it as much as you need to. Thousands place. So 7 tells me to round up. So that's how I got 475 thousandths. With this last one right here, since you have all those 4 digits repeating, you're not going to have to go that far. So that's why you have 7 tenths, 71 hundredths, because it's the 4, you round down, and the 2 in the 10 hundredths place, so you round down to 714 thousandths. Right, so here's an example of a word problem about how many Blu-ray discs at $29.99 each can be purchased for $154. Well, you could divide if you wanted to. It's a little complicated if you do it by hand, But if you do it by hand, you can always round. So $29.99 is approximately $30. To make it nice for myself, I can round $154 to $150. Divide those two and I get 5. So then what I can do is just do 5 times the $29.99 times 5, and that gives me $149.95. So without doing the crazy long division, you can use estimation to solve it. And see how close that was? If it went over, then I know that I can only do 4. All right, so a couple more examples. Now we're going to look at square roots and Pythagorean theorem. And with these, you can start using your calculator. And basically for this, you only need a scientific calculator. So it says, find each square root. Where necessary, use a calculator, round to the nearest hundredths place. So taking the square root of 324, depending upon your calculator, you might have to do 324 first and then do the square root. That's what I do with this one. And I found that was 18. That's the answer. Square root of 189. Again, type that on my calculator. I get 13 point something with a crazy decimal. Notice that it doesn't repeat, and with these decimals, they're not going to repeat if there is one. So you'd round it hundredths place. So that 7 in the in the thousandths place tells you to round up. So that would be approximately 13 and 75 hundredths. All right, last but not least, I guess I forgot to do something there, but we know what we're going to get into. So whenever you have a right triangle, you're going to use Pythagorean theorem. That's a squared plus b squared equals c squared. C squared is whatever's opposite of the right angle, which is your hypotenuse. Here it's 17, and these are the legs that are adjacent or next to the right angle. So that's 8 and x. Those are going to be the legs, the a and the b. Here it doesn't matter. You can switch a and b. The numbers, it doesn't matter. The only thing that matters is that you separate the legs and the hypotenuse. So you plug those in. So it's 8 squared plus x squared equals 17 squared. I used a calculator to calculate those. So I got 64 plus x squared equals 289. Your calculator doesn't solve an equation, so you can use the calculator in the in-between steps. So I need to get rid of 64. So I would subtract both sides by 64. And I get x squared equals 225. And then what you would do, you do the opposite of squaring something, which is square rooting something. And when you have an equation, whatever you do one side, you do the other side. So here we're going to take the square root of both sides. The square root of a square just cancels, leaves you with x, equals square root of 225 is 15. Now elsewhere you might see like a plus or minus or anything like that, but since lengths are always positive, you can ignore that. So when you take the square root of a number, that's what you get. So the answer is 15 for that missing side. So what did we go over? Let's review. So we went over place value and rounding. We went over adding and subtracting decimals, multiplying decimals, dividing with decimals. When you're adding and subtracting decimals, the key is to line up the decimal. Multiplying decimals, you can ignore the decimal at the beginning, but then you use it at the ends. Dividing decimals, you want to make sure that whatever you're dividing by is a whole number. So you might have to shift the decimal. If you do that to one number, you have to do it to the other, which it's called a dividend and divisor. You would have to shift both of those. And then you just, wherever the decimal ends up, you just put it at the top there. Repeating and terminating decimals, we compared the two. Terminating decimal ends, repeating decimal repeats. Then we looked at the square root. So you would basically use your calculator for that. And then Pythagorean theorem, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. Thanks for watching this video. Please like, share, and subscribe. And if you have any questions, put them in the comments below. Thank you.